Hey, welcome back. In this video we are going to discover a couple of very powerful features in ES6, which are the rest and the spread operators. So, unlike many other languages, a function in JavaScript can accept any number of arguments despite the number of parameters set at its declaration. In this example, the maximum function is supposed to take two arguments and then prints the greater value. So, if we call this function with two arguments, everything should be working as intended, nothing special here. Now, if you have a prior experience with another programming language like Java, you may expect to see an error message if we call maximum with a third argument. Well, that's not the case in JavaScript. The function still works and it gives the right result no matter how many arguments we pass to it. However, when I say the right answer, it means taking only the first two arguments into consideration because the rest is simply ignored with the logic we have within this function's body. Now, say we want this function to print the right result even if we surpass the number of parameters set at the declaration of the function. To do that, we need to make use of the array-like object named arguments, which holds the function's arguments. As you see, calling maximum now with more than two arguments gives the correct answer regardless of the number and the order of the arguments. Actually, we can get rid of the parameters in the function's definition since we are not bound to a certain number of parameters. That being said, even though this approach seems to be working fine, it has a couple of drawbacks. You have probably noticed that earlier I referred to the arguments array as an array-like object. That means that this is not an actual array, even if it seems like one. To prove that, we can use the instance of operator to check if arguments is an instance of the array object or not. And the result, as you see, is false. Now, the problem with this type of objects is that they are limited in capabilities compared to actual arrays. So, methods like map, reduce, or for each, for example, don't work on them. Let's give it a try and see what will happen when we call for each on arguments instead of using a typical for loop. And there we go, a big error message shows up saying that it doesn't recognize the for each method since it doesn't belong to this type of objects. The second drawback of this way of function definition is that the function's signature is misleading because it tells that the function doesn't take any arguments, whereas it actually takes an indefinite number of arguments. So that said, ES6 introduced a solution to both of these problems, and it's manifested in what is called the rest operator, which works a bit similar to arguments. To use the rest operator, we just need to type 3 ellipses followed by an identifier, and that's it. And now we need to replace all the arguments occurrences with the new identifier. As you can see now, not only the function's signature tells that the function takes any number of arguments, but also the argument's replacement, which is the values variable here, is a real array. To use the rest parameter, we need to follow a couple rules though. The first rule is that a function can have only one rest parameter. The second one is that the rest parameter must be placed as the last parameter of the function. Something important to keep in mind is that the rest parameter holds only the values of the unnamed parameters, unlike the arguments object which holds the values of all the function arguments. In this example, if we call the function with a single argument, the values array stay empty because the argument is set to the val1 parameter. Calling the function with two arguments also leaves the values array empty because the second argument goes to the second parameter, which is val2. Now, on the other hand, calling the function with more than two arguments, the values array will contain the values of any argument that comes after the first two. Say we have an array that contains some values and we want to use the max method to get the greatest one of them. If you're familiar with the max method, you probably know that it doesn't take an array as an argument. Instead, it takes discrete values, and therefore we need to pass each value from the array as an argument. The problem with this is that in a real-life example we may have to deal with arrays that have thousands of values, so manually passing each value as an argument would not be a reasonable option to consider. A good workaround is to call the apply method on the max function. As you can see, this approach works fine, but it still looks a bit confusing with that null as an argument to the apply method. JavaScript developers used to go this way in similar cases until ES6 came with the spread operator, and this is how we use it. We just need to call the max function and then type 3 ellipses followed by the array identifier, which is values in this example. It may seem a bit confusing because the rest operator looks pretty much the same as the rest parameter. Well, maybe the notation is the same, but the rest is different, because if you look carefully, you'll see that we are using the rest parameter in the definition of the function, while we use the spread operator in the function's call. That aside, the roles are also different, as we can place the spread operator anywhere we want, since the order doesn't have any importance. Not only that, but we can also use as many spread operators as we want. Now, say we have a function that takes only two parameters, and we have an array that contains values to pass as arguments to that function. So typically we have to pick the values using the brackets notation to pass the arguments to the function. However, we can go the easy way and just use the spread operator. As you can see, the spread operator takes the same number of values as the number of the function's parameter from the array, and then pass those values as arguments to the function. In this case, it took the first two values from the array and passed them as arguments. That said, let's try the same thing with the third parameter. And there we go, it works the same way. Now let's add the rest operator to the function and see what will happen. As you can see here, the first value of the array was taken as the first argument, the second value was taken as the second argument, and then the rest of the array was taken as third and fourth arguments, and were placed in the other array, which we transformed into a string using the join method. The spread operator has more use cases than just spreading the values of an array as individual function arguments. Let's create an array and then make a copy of it. So here the values are the same in both of the arrays, nothing unusual. Now let's try to add data to the copy of the array. Can you guess what the result will be? Well, the first answer is the right one. That means that pushing new values to the second array affects both the original and the supposed to be a copy, and that's because the second array is not an actual copy of the first one, but it is nothing more than a reference to it. I know this may seem a bit confusing, but for now I just want you to think of it this way. Using the typical assignment doesn't create copies from arrays, it just creates a reference to the original array, and I'll explain that in details in a separate video. So back to our main topic. To create a real copy of an array, we just need to use the spread operator this way. Furthermore, we can use the spread operator to concatenate arrays into a new one. The concatenation doesn't need to be made out of spread arrays only, since we can also add any type of values. The same exact thing goes for objects. In fact, we've talked about that in the block level variables part of this series. So, if we try to create a copy using the equality sign, we'll just get a reference to the original object. So again, if we want to make a real copy of the object, we just need to use the spread operator. And finally, same as we've just seen with arrays, we can use the spread operator to create a new object made from the fusion of the already created objects in addition to some new properties. And this is it for this part of the series, so make sure to subscribe and I will see you in the next one.